start with talking about the renewable energies. So what is the particular interest about the renewable energy? Can you please start off with, sir?
So I think this is the most hot topic in the country today because every corporate, every industry, every government body is trying to do green transitioning. So there is a huge demand for renewable power, not only from institutions, but across the country, even including individuals and households. So this renewable revolution is here to stay. I think if we have to um, benefit from this 1.5 degree reduction, I mean, we are talking about not hitting 1.5 degree of temperature rise, which is the whole idea, which was signed up earlier. And that, if you look at it, we are talking about the carbon budget available is around 440 gigatons for 1.5 degree. And if you're talking about 2 degrees Celsius, it is 700 gigatons. And we as a globe is already emitting close to 44 gigatons per year. These numbers may be plus or minus a little bit here and there. So that means we have like 10 to 11 years to exhaust this carbon budget. And if we are lucky, then we talk about maybe 18 to 20 years of where we'll reach a point of no return. So I just want to impress the audience here that this is not a trivial matter. This is really of concern. And the quantum of investment required to do this transitioning in the globe is going to be into trillions of dollars. Some estimates put it as $100 trillion. India itself will need $1 trillion for this transition at the moment, based on the estimates that we've seen. So this is a very, very current topic. I think looking at the kind of weather that we are experiencing in the last couple of decades, it is a no-brainer that there is a real problem at hand. And while we may all want to push it under the carpet, it is here to stay. I think the good news is in the last 5-7 years, there is a lot more acceptance of transitioning. We have seen regulators also pushing in that direction in terms of reporting. The stock markets are actually giving value for companies that are becoming more sustainable. At the board level, there is a push towards green energy. And also from the customer perspective, in you're looking at exports, like there is a CBAM that is coming in from Europe from 2025, which will be an carbon-based adjustment mechanism, which means if you are importing from outside Europe and you're not using renewable power, then there will be additional tax levied on those products, which means the supply chain needs to be greened across the board. Now, how is all of this relevant in the context of this event? I think cloud and data centers are one of the foremost players in the renewable transition, because a lot of their customers are actually asking for green energy, and they would not sign up with data centers if they don't give them green energy. We as Radiance are one of the leading players supplying renewable energy to sort of data center companies in India. And when I looked at this around 3-4 years ago, the data center market was supposed to be like 5 gigawatt of energy by 2024. Now we are talking about something like 8 to 10 gigawatt in the next 3-4 years. So there is a huge requirement. I was watching one show recently in the BBC which talked about what is the carbon footprint that you emit when you just do a 1 hour of streaming of video on your mobile phone. It's around 36 grams of carbon, that is what you do. But the moment you move to artificial intelligence and generative AI, or for example, you create 10 pictures, some 10 paintings you get from any of these platforms, that itself will consume power which is equal to 2.5 times of your battery charge of your phone. And if you look at when you run generative AI, this can really take a lot more energy of close to almost 2,500 tons per year. So we are talking about moving away from pure search as a mechanism to something like generative AI, which is where the market is moving towards. It's not to say that it is not going to happen. It will happen. we have to find ways in which we can satiate the demand of data centers. There is an opportunity here for data centers to reduce their consumption, improve energy efficiency, and also go green. So I think with that opening remarks, I will just sort of leave the forum for other participants to mention.
Yeah. Good afternoon to everybody. So I think this climate change, it's there to be seen by all of us. It's really happening across the globe, and in India also it's happening. So you could see what's happening to the floods and increased temperatures across all our HVAC designs has to be tweaked based on all these requirements. So I think it's part of the community. We need to look at renewable energies very strongly for all the projects. I think there is a commitment, as he said, by all the corporates to go energy neutral by certain years and water neutral as well. So I think this is the demand the industry is seeking, and a data center being an energy guzzler, we need to look at it very strongly. In the morning, the ACE officer spoke. I think out of 32 gigawatt of power in Tamil Nadu, 50% is through renewable energies, both solar, wind, and hydro. So that's a huge, the state has taken a huge step forward in doing this. I think when the state does it, individual corporates has to do it, individual people have to do these things. So having said that, data center, I know it's in huge megawatts, how to do it in a data center. So I think the freewheeling, I can quote an example for our data centers. We were mandated to give 25% of renewable energy in a 40 megawatt requirement of a data center. So we have given to the government, we will do that in the next 3-4 years. So we are setting up solar farms in some other place and freewheeling and taking it. These are some of the methods we can adopt to use renewable energies in this data center. Our corporate from L&T also has committed that we'll go water neutral by 2035. That means whatever our own projects will be water neutral, and probably within the next 5 years will also be carbon neutral. So this is the commitments all of us take in the organization to achieve this. There are newer technologies which are coming apart from solar and wind. I think we need to explore that to achieve this in the data centers. There is a battery storage systems, and there is hydrogen power. So clean powers are being researched, and we need to adopt this for big power guzzlers like the data center. This is my opening remarks.
Good afternoon. Good afternoon, everyone. So I'm Nagendran, heading IT infrastructure and data center operation in Ramco Cements Limited. So particularly my specific interest towards the renewable energy is that its sustainability and the cost benefits. At Ramco Cements, we have set up the windmill setup over late 1990s. Okay, so it's almost 3 decades. So now around 40% of energy mix we are using for Ramco Cements major cement operations. But today, as Manikkan said, that renewable energy has become a hot topic. It means it's not a new topic. Over 3 decades that a lot of lot of forums are talking about the renewable energy, that usage of renewable energy. But why today this topic has become the hot? Because the data center is the major power center for many. So in the modern lifestyle, we are every day we are using from the industry 4.0 and AI, ML and Gen AI. These kind of things are utilizing more and more power in terms of data center. So in today's world, data center is utilizing more power comparing to as much as like us the industries, right? So this is the hot topic today. So my specific interest towards the question is its sustainability, and we will get the cost benefits when we use the renewable energy. Since we are a real benefiter, we are already using around 40% of energy mix in our factory operations. I am just saying like this.
Good afternoon all. I'm Hariharan. I represent a company called Gulf Asia Engineering and Projects. Our core business is EPC and one of our other businesses oil and gas. So when it comes to the renewable energy, a clean source of energy, yes. So it's the current topic, though we have been talking about global warming and a lot of things, for almost 1 or 2 decades. So earlier, so now what we're looking at is what are the kind of clean energy that we have. So other than solar and the hydrothermal or the tidal and the wind, etc. So we also have some amount of the biogas and other related clean source of energy. But coming back to the specific topic of how do we manage the excuse me. So how do we manage the renewable energy? So the main thing to look at is specific to our continent Asia, or specific to India's more of solar and wind, so that we have in abundance. So specific to our current today's event on the data center, and then how do you manage the cost and how do we take it further. So there are a few more points, and we have the expert panel talking about renewable source and how do you balance out the expense and how do you balance out the customer expectations, etc. So that will be the topic that we need to further talk about. Thank you.
Okay, sir. So as we are now in Chennai, so now we will talk about the Chennai. So where in Chennai the data centers are using renewable energies, and which form of renewable energy is leading in the market in Chennai? Yeah, anyone, sir?
So, of course, we are in Chennai, but before talking about specifically to the Chennai, I just wanted to tell about how the Tamil Nadu is progressing on the renewable energy. So today morning session that Vishnu, that IAS officer from Guidance, he has mentioned many facts from the government point of view. In that, I just want to highlight one specific statement. Today, we have around 34 gigawatts of energy needs for the as a whole Tamil Nadu state. In that, around 17 gigawatts is coming from green power. For Tamil Nadu, it is 50% of energy mix we are using in the Tamil Nadu state. It of course, Chennai, it belongs to the Tamil Nadu. So we can take it, Chennai is also utilizing 50% of green energy in the various sectors, not only in the data center, in various industry sectors also, we are using the green energy, right? So in a data center per se point of view, already we are seeing many large scale data center operators are setting their services in Chennai. Just say for example, L&T and Capital Land, those are the few of the name I'm just giving you. So they are providing that co-location services. So using this co-location services, we can set up our data center in that, which is using the renewable energy. So in short, should I tell that we are already in the middle of the river, our feet are getting wet in the renewable energy segment.
Yeah, just to add on to what he said, the Tamil Nadu government also has declared, I think probably 26, 27, because of the growth of data centers in this state, will reach around 47 gigawatt is the power requirement by 26, 27. But they are aiming to have 75% of renewable energy by that period. So it's a great leap. So most of the powered sectors, whoever is taking power apart from data center, you will be on green energy. So that's the aim the government is there, and we should do our part to support that. Okay. Another thing is, when we do this renewable energies, there are new technologies also are coming. I mean, I think L&T also is into that green energy. We are developing electrolyzers for making energy produced out of hydrogen and other things. So going forward, that could be the replacement to the generator sets in the data center space. So this is something I would like to tell.
Thank you. I want to just say that actually Tamil Nadu is one of the foremost state within all the states in the country in terms of renewable energy. As Mr. Nagendran also mentioned earlier, they have been using wind source for more than 30 years now. So it's not unknown technology. It's a hot technology right now, but it's not unknown. So the reason for that is that Tamil Nadu has always been very short on thermal resources. It has got a few lignite power and it has got a few allocations from the center from the nuclear plants. So it always needed power for its own industrial requirements, and with the foresight of the bureaucrats of the government, they were able to open this market much earlier for renewable energy. And because Tamil Nadu also has the benefit of being having a good wind resource, and there was a tax depreciation available at that point in time, the market just took off in Tamil Nadu quite a bit. At that time, in 1990s, mid-90s, people were not thinking about renewable energy, but they were thinking about saving in cost and availability of power per se. That drove that market in a big way. So the government policies has been very, very supportive of using third-party power, third-party open access power, using captive concept, group captive concept, which are some of these concepts that are being fought about in other states. Now, fortunately, with the Supreme Court judgment, it is pretty clear that you can have multiple customers in one project and taking up 26% equity and 51% of the offtake of the energy from a project. That paves the way for the sector in a much better way. Coming back to Tamil Nadu again, I think there is enough solar resource also available in Tamil Nadu. I think we are looking at projects which are hybrid in nature because of the unique opportunity of having solar and wind together. As was mentioned earlier, that while the government would like and everybody is trying to put more renewable energy into the grid, the one problem that will start cropping up is that the grid becomes pretty unstable because the power that you get from renewables is not very firm power. It is not like a gas turbine or a coal-based thermal plant you can start and switch off when you want, because when the wind blows, it blows, you get the power, and when the sun shines, you get it. The good news is that because in Tamil Nadu you have resource, both wind and solar, you will have the ability to provide daytime solar power and nighttime wind power, and also some wind power during the day. And also the interesting thing is that you have double monsoon. So you have the benefit of two wind zones. So it's another benefit that Tamil Nadu, because of its location, has the benefit. So I think the way the renewable energy market, how it will support the data center industry, the way I see it is that basically there will be more projects which will be solar or solar plus wind or solar plus wind plus storage. Now the storage would be, everybody is hoping it will be through battery storage. Unfortunately, during COVID, there were 2 years of, the price didn't drop for the batteries because of the raw material and the supply chain issues. But it's now coming down. So hopefully the Moore's law will take over and the battery prices will come down, and we will see that that will drive the storage. I think for data centers, my understanding based on the customers that we have, like for example, we have one customer in Tamil Nadu, we are giving 200, sorry, not Tamil Nadu, Maharashtra, we are giving 200 plus megawatt from for a single customer from a single project. It's a very large project that we are setting up for them. What we find is that data centers have very stable load. Their variation in load is very limited, so maybe 2 to 3%. So it's the same for day and night. So it's actually a very good customer load profile for generators like us, because we can't handle both sides of variability, where the load is also varying and the generation is also varying on the other hand. So this provides one level of comfort, which means there is an opportunity for data centers who are very large data centers with very high IT load to start looking at also contracting on ISTS basis. What I mean by ISTS is interstate transmission system, where you produce power in high resource regions like Rajasthan for solar, wind could be in Tamil Nadu, Karnataka, Maharashtra, Gujarat, any of these locations, and virtually blend the power on the national grid and get power on a 15-minute slot basis to the customers who are like data centers who have a very static load. What happens is that that transposes the problem onto the generator, how the problem then becomes a forecasting and scheduling problem for the generator. But that's a challenge that generators are now working on with and seeing how we can help. And that also allows us to buy and sell from the exchange to balance out the shortfalls or excesses. So these are things that are happening in the market from the renewable side. So for all those people who are from the data center side, I thought this would be a good information for them to know that you can look to procure renewable power not only from the state in which you are present, but you could also procure renewable energy from other states through interstate transmission system, provided you are at a reasonably high EHV voltage level, which in my assessment, most data centers are at 110 to 20 kV and above. So it makes it easy for them to procure. They are actually the best customers who are suited for this, apart from the iron and steel industry, who are also connected to very high voltages. So that's an opportunity for data centers to start greening faster and also start looking at hybrid projects through interstate transmission system. So this is something I thought I'll add to what was said earlier.
Yes, sir. As you told, sir, a lot of energy has been coming inside our data centers and all. So if excess of energy is there, so is there any option to store ourselves for the future use, like cells, battery cells or something?
Yeah, so I think the battery storage can be thought about in two forms. The storage can be thought about at the customer point, or can be thought about it at the generator point. Because as far as you are concerned, you need power which is green, which is there available throughout the day. That's what you want to see. This is a new requirement. So what we call as firm dispatchable renewable energy is called the FDRE. Government has come out with some bids on the public sector side of around 1,000 megawatts. It's still at an experimental stage. So that kind of FDRE bids can also happen in the cloud data centers, where private transactions can be done between generators and customers on FDRE. Although I think that the cost economics today are not the most sort of feasible today, but I'm confident that in 2-3 years' time, those models will become more matured. So what we are looking at is to provide a sort of 50 to 60% sort of slot matching for customers, because anyway, most of the data centers are also connected to the grid. So the moment you go higher and higher to firm dispatch to 90% or 80%, then the sizing of the batteries and the sizing of the solar plants becomes so high that even during normal slots, you will be producing more power, and you have to sell it at the exchange, or you have to put it up into batteries. The moment you put it on the batteries, the cost of the batteries are still very high. Yeah. So it is not very economically viable for our customers. So what we advise them is that you look for a 50 to 60% sort of what we call RTC, round the clock power. And the remaining you can anyway take from the grid for now. 3 years, 4 years down the road, if the battery prices start collapsing significantly, I think then the firm dispatch will become more and more viable. Anyway, this is a very new concept. So at this stage, even for data centers to reach 50% of their power from renewable is still not happened, right? They are still trying to get to 20%, 30%. Pure solar will give you roughly around 20-25%, maybe up to 24-25%. And if you bundle that with wind, you could easily go up to 50%, depending on the sizing and the resource where you are present. So yes, it can be done. But my advice is that putting a battery at the customer point is not a very useful option, because it doesn't help you in any way, really speaking.
Okay, sir.
Yeah. So to add further to that, so in our client projects in Saudi or Qatar, so ours is like, a construction or an oil and gas kind of a construction project. So that land, that tenure is like 3 years or 5 years kind of a construction. So in that case, yeah, so Saudi or all the Middle East countries, yeah, you have abundance, solar power. So in that case, solar kind of, tidal as well. So what we do was we try to, capitalize on the source or the energy that we produce, and we try to use it for the X or Y clients. So I don't want to name the client's name. So we try to, capitalize on that, and then that will help us, in reducing our OPEX and also add value to the clients, because we are using the clean energy. and that adds value. So that is one of the key criteria as part of a checklist or a kind of a to-do list that we have for any client projects. Yeah.
Okay, sir. So now, as we are talking about the transition, a green transition, so now how the transition is taking place, as your experience, can you tell some use cases or something? How the data center is changing to the green energies?
So, as I said, one of our data center, our own data center, we have promised 25 to 30% as renewable energy, and we got a platinum certified data center. That is, so we are committing. And what we are doing, because the land availability within the data center area is limited, so we cannot put all the renewable energies there. So we are putting it in some other place. There is a power agreement also possible. We have done 2 steps. We are putting 10 megawatt of our own thing somewhere else. And then we are also having a power agreement signage, buying the power, green power. These 2 methods we are using to satisfy this renewable energy.
Okay, sir.
Sir, in my point of view, the environmental enforcement policies and corporate social responsibility mandates and energy cost benefits will encourage this transitioning for the renewable energy. But I'm thinking the biggest barrier in this transition is the initial investment cost for setting up the renewable energy plants. So it's keep away many firms to use the renewable energy. So for this, both governments and private sectors make the combined efforts and bring some kind of easy accessible for renewable energy. For example, the data center co-location, which is using that renewable energy, which is the best example for this.
Okay.
Yeah. To add it up, yeah, so it's not only the initial investment, but also how do we store and reuse the energy, or try to use it across the multiple clients that has been co-share or co-located places. So in that case, that is also one other point that we need to look at, and that adds value to the company. Yeah.
Another thing to this, I mean, renewable energy, when you're taking, you will also look at how energy efficient you're making your data center, because these are all huge powers. So you will have to focus on the type of equipments you're buying for the data center, do a proper analysis and reduce first that's what we were talking about, PUE and all. This all matters. Then you can get a renewable energy which is less required for the data center of that capacity. So I think we have to do it 2 ways. Yes, plan for the renewable energy, but also look at the data center designs to make it more energy efficient.
Just want to add one point to what Mr. Nagendran mentioned earlier, that while the investment cost for renewables is significant, I think that is where companies like ours at Radiance Renewables, we are not asking our customers to make any investments in the projects. We are doing that investment, and we are providing renewable energy as a service to our customers. So what they are doing is they're basically signing up long-term PPA or energy supply agreement contracts like the one that Mr. Balakrishnan mentioned earlier. And the customers then put minimum equity investment to qualify for captive projects, because there is a significant saving in the cross-subsidy surcharge and additional surcharge, which doesn't have to be paid if you have a captive project. So that gives huge payback within less than 1 year for most of the customers. So I think on top of it, there is a 30 to 40% reduction in the energy bills from day one, which is hugely beneficial for our customers. So we see that the investment case is definitely there for us to make an investment, because we make a generic return on it as an infrastructure as a service. For our customers, there is immediate value creation for their business, and not only from getting economic benefit, which is what Mr. Nagendran also mentioned, that the cost is saving is there, but second, you're also getting green power, which has got so many other benefits in terms of meeting your requirements under CSR and customer requirements and other things. So I think it's a no-brainer. I think a lot of customers are now designing their data centers and designing their requirements in such a way that they need to sort of meet these twin goals of economic efficiency in terms of the pricing and also in terms of the green part of it. So I think there is a huge opportunity. The only challenge in data center business, what I understood is that unlike a steel plant where they know they're going to put up a 1,000-ton plant or a 500-ton plant, here they would say that this is what we want to go to, but we will keep adding racks and we'll keep on requiring the power. What happens is that when we decide a plant for putting up a solar or a wind, we need to know what is it that you're going to offtake, because we are not going to build a 5 megawatt project. We build a 100 megawatt project, and if you're taking 5, that's fine. Somebody's taking 20, that's great. Then you come back after 6 months, say, I want another 2. Then you got to wait in the queue because we don't have those many projects to give. So I think that planning part is very important. So we worked with customers where they say, okay, you want 5 megawatt now, but what is your plan? So they say, going to add 2 megawatt IT load, 5 megawatt IT load every month. And they say, this is our requirement quarterly. And then we work with them and say, okay, this is how we'll build it, and we can. So I think it's a solutioning that is very interesting for this sector.
Okay, sir.
Thank you.
Yeah. So now we are talking about the renewables. Now, who is responsible for it? Renewables to be, it has to be go and reach the data centers and the end users, or national or regional persons.
I think the responsibility always starts, it's a two-way street, right? So if companies say that we need renewable power, I think there are enough companies who are providing renewable energy service, like ours, and there are a few others also. So they come out and say, we want it. Now, when you question about regional versus central, that I think the responsibility of providing a conducive environment, policy environment for adoption of green, that lies with the state largely, because if the state makes it very difficult by not granting connectivity approvals or those kind of things. We have seen that in the case of, I won't name the state, but not this state, a couple of other states had difficulties where there are a lot of IT companies present there. It's like like a Silicon Valley, not Karnataka, but a different state, where you can't get connectivity. So people have come to us and said, can you give us? I said, I'd love to give it to you, but will you manage the connectivity? I can't get connectivity. So of course that the policy is also changing in those states now, and I think the states are also becoming more progressive as they see that there is an option for industry to relocate to other states. For example, data centers will not go to states where the green policy is not good enough for them, because they have an obligation to have green power to their customers. So they will choose the states which are friendly, where there is focus from the government to support by way of policy, and where generators like us can provide that kind of opportunity to them. So I think the responsibility lies with everybody.
Yeah.
State, center. Center has done a lot of positive developments, like they come out with green energy open access rules, which has now been adopted by the ERCs, electricity regulatory commissions of every state, and they have made that easy. They come out with a program for the interstate transmission system. They come out with general network access rules, GNA. All of this they have promoted. Now, ultimately, it has to get translated at the state level. And of course, the customers, like data center customers and other customers, they also need to keep pushing the state to make it friendly enough so that they can adopt it better. Thank you.
So, in my point of view, both the central and state governments, along with the few of the private sectors like Radiance Renewables. So if you see that pyramid, in the top of the pyramid, in this case, in this specific situation, that government body should come. In the middle, the service provider, like and in the bottom, the people who are using running the data centers using the renewable energy, right? Without that government's any specific norms and policies and regulations, even service provider cannot make it that renewable energy more accessible to the end users. So in this case, the good news, already our government, both central and state governments, are on track, as India is a net zero carbon emission country which aims on 2070 as per the central government recent statement, while the Tamil Nadu state is in the net zero carbon emission state. Is the 2050 is the aim for Tamil Nadu state government. So the good news, the government is also on track to encouraging the usage of renewable energy. So it will slowly become, we will achieve the net zero carbon emission.
I think only one question for the internal panel. I think the energy cost generated to renewable energy, I think there is an issue between state center and the service provider. You can throw some light on that.
I think when I was referring to the 30% saving in cost, I was referring to like cost. So the price of power, so the way we price the power is we price the power at the injection point, or what we call as a delivery point, which is if we are connecting at 110 kV bus bar, then that's the price at which you inject it to the grid substation at our end. And you are located in some other location, and you will be taking power from connected probably at the 110 or 220 or above, so long as you are in the transco circle, and you will be taking that power. So what happens is that the way the charges work is from the point of injection to the point of delivery, I mean to the point of consumption, what you call as the customer bus bar. So depending on what you use, if you're using the transmission line, then there are transmission charges and transmission losses. And then if you are stepping it down further and you are using 11 kV connector feed or a 33 kV is okay, 11 kV or up to 33 kV, you will also be, most probably be in the DISCOM circle. So in the DISCOM circle, you will also have to pay the distribution charges, distribution losses, wheeling losses, what they call it, right? And wheeling charges. So when you add wheeling losses, wheeling charges, which is part of the DISCOM cost, then you add the transmission loss and transmission charges. These are the basic costs for any open access customer. Provided you are also a captive customer, these are the only charges that apply to you. The moment you are not a captive customer, that means you don't own equity in the project, then you become a pure third-party open access customer. You are allowed to take power without putting any equity. Then you will also have to pay additional costs like cross-subsidy surcharge and additional surcharge. Now the cross-subsidy surcharge and additional surcharge in states like Maharashtra can be 2.5 rupees per unit. Now in the state of Tamil Nadu, it is a different number depending on the voltage levels where you're connected. And so that varies across state to state, varies across the customer category. So there's a whole chart around it. But when I talked about 30% saving is after I take into account all of this cost, what lands to you still is 30% cheaper than the grid price, right? And if you're consuming power in the day and the night, you have multiple slots, time of the day slots in which you're consuming power. So what we do is we look at the weighted average cost of consumption in those slots with the price in those slots. And we work out this is your weighted average cost at which you are buying power today. And if you move to green, what is that cost landing up to you? So that's what we look at. Then there is a concept called banking, which is available in Tamil Nadu, is available in other states. The banking is when I put power in the daytime, but I want to use the power in the night. So effectively you're using the grid as a battery. So the grid may also suffer from that point of view. It was allowed in Tamil Nadu also in many states as an annual banking concept. So you can bank it anytime in the day, and you can take it up anytime during the month for the whole year. But now it is becoming difficult because more and more renewables is going into the grid. So the DISCOMs don't want to take on responsibility for providing banking beyond the month. So within the month, they allow you to use it, but they won't allow you to take forward to the next month. These are for new projects. Older projects are somewhat grandfathered. And this is the concept for both wind and solar. So the banking is a monthly banking is what most of the time we see now, and it is across the state. But states have been very positive in the sense they are trying to allow you to set off peak power with peak generation. And if you generate during the peak, they also allow you to offset in the off-peak time. But if you're generating in the off-peak time, like a wind in the late in the night, you cannot offset it with the peak time. So there are those kind of regulations. We sit with our customers, we educate them, because it's not a topic that is very well known for customers. And our way of selling is that we don't sell the power at a price. We sell the solution, which includes making sure that you're going to make savings. If you're not making savings, then we are not doing our job. So that's how we look at it.
Okay, sir. So now, as part of renewable energy for future, which type of renewable energy will be going to be the future for us? Like wind, solar, nuclear? Can you please explain this?
Thank you. So I think India is one of those very interesting countries where we have more than 300 days of sunshine, and most part of the country. There are very few parts of the country which doesn't have sunshine. So I think predominantly solar will be still the large generation. I think we also have good wind resources in a lot of states, like as I mentioned earlier, Karnataka, Maharashtra, Gujarat, some parts of Rajasthan, Tamil Nadu, of course, and some of the other parts of, like Madhya Pradesh, you'll find some parts of it. So what has been the reason when this whole industry started, it didn't start with solar, it started with wind, because wind was making sense at that time because of depreciation tax benefit. Then there is a point that reached where solar at that time, the capital cost was so high, it was costing $2 million a megawatt, then it's come down to $500,000 a megawatt. So that is because when you're dealing with semiconductors, you have the benefit of the Moore's law. And every year the price started coming down and you benefited out of it. Wind doesn't have the same benefit because wind uses a lot of mechanical components, mechanical parts. So wind industry is able to reduce the price of power and the capital cost by increasing the height of the turbines. And now we reached up to 150, 160. There are even, of course, bigger turbines. So the challenges there is construction time and construction cost for wind projects are much bigger in terms of cost and longer times for delivery. And solar is relatively faster in terms of delivery of the project. But at the same time, you cannot say one without the other, because I can't supply any power in the night with solar, because there is no sunshine in the night. And I need wind power in the night. So I think a good blend of solar and wind based on the resource will be actually the right way to go. I think hydro, of course, is a very good opportunity, because hydro can act as a battery as well, because you can instantly run the turbines and get more power. But what's happened is that large hydro projects are not likely to come in India because they have a lot of ecological disturbances. You have villages submerged, rehabilitation, relocation. This is not going to happen. The projects that we built in the olden days, that's over. I don't think we're going to see a Three Gorges Dam like China built in India anymore. We're not going to see those. Last thing was the Narmada project that we saw. So we're not going to see those kind of projects. Small hydro projects have limited potential, but they are good. But they are like 10, 15, 20 megawatt projects, not bigger than that. So predominantly the market or the generation market will be largely solar with good amount of wind. Today we have like 46 gigawatts of wind. We have more than 80 gigawatts of solar, and together like 175 gigawatts of wind, solar, hydro, biomass, everything put together as a country. So I think this mix will probably be in the same way. I mean, coming to any other sources, of course, nuclear is not necessarily considered as renewable. But yes, that's the other market that I heard that somewhere that some of the data center companies are thinking of putting their own nuclear plants. So I was wondering how they will achieve renewable target on that. But it's an interesting development. So I think this will be the mix that will largely be in place. Hydrogen as a market for India, I think, is largely for usage in ammonia. We don't have seasonal shift of power, which is there in some of the largest Scandinavian countries. They need to shift power because they won't have any sunshine for 2 months of the year or 3 months of the year. So there hydrogen becomes a very useful seasonal shift. We can't use hydrogen to do seasonal shift because it's not required for our market. So I think hydrogen as a use of power will be largely used for creating ammonia for the shipping industry, ammonia as a product to sell. So you convert green electrons to green molecules and you sell it in the external market. So there are different kind of opportunities there. Thank you.
So please.
Yeah, probably I agree with him. Solar will be the predominant thing, but there are other technologies like fuel cells and other things which could come up in the market and take over. There's a lot of R&D going on green energy products. Probably that will take some few years to come up, but it will definitely come.
Yeah. So in terms of renewable, yeah, the choices are plenty, right? Like we all talked about, but how do we handle the value chain, right? And how do we, make use of the byproducts of, the energy that we produce? How do we store it? And how do we, try to cross sell or, bring in the awareness? So that's how we need to look at.
Yeah, I think we are running out of time, so I just want to say quickly. Of course, I cannot say too technical like how that Manikkan has said because he is that industry expert on this. So in my point of view is, though we have a early adopters for wind energy, and we are leading in the solar energy power. As of today, we are just have a 50% of mix, energy mix. To make it 100% of energy mix, we should explore for the offshore wind. This is the vast advantage of there, because we are in a seashore area of the state. That offshore wind is the very good alternate source for us, and likewise that hydro and the pumped water storage. Those things are the other opportunities. So if we use all these technologies, sure we will become as the 100% of energy mix in near future.
Okay.
Just want to add one point. I think it's a good point you made about offshore wind. I think that's India with a vast coastline has a huge opportunity there. But right now, I think the economics is still not stacking up there. I think it's very complex right now. I think there is one more opportunity which I think companies like Ramco can definitely explore, because they have been having wind power for such a long time. There is an opportunity to repower your existing wind farms, because a lot of those wind machines which are 25 years old probably were 250 kWA, 500, 750, 1.25, 1.5. Now I think the newer machines that we're talking about is 3.3 meg, 4 meg machines, which are taller but needs to be consolidated. So if you have contiguous land and you as a large company own it, you have the better chance of doing it than those individuals who bought those turbines. Consolidating them is a nightmare, and that's not going to happen. But I think the offshore wind farm has a huge opportunity, provided there are very clear policies on who is going to build a substation, how are you going to evacuate the power from the offshore point to the landed point. What is the benefit? Because the costs are going to be higher for offshore wind turbine calculation. So you have to really go bigger size, bigger capacities, 12 megawatt turbines, 16 megawatt turbines. So then it's a different ball game.
Okay.
Thank you.
Okay, thank you, sir.
So I think we'll move on for just a couple of question and answers if the crowd has.
So any questions?
Yes, this is Akila from L&T. While we talk about the renewable energy, I just want to understand whether are we also in the energy reuse, especially with respect to the data center, which generates a lot of heat.
See, I cannot talk about directly how we can generate the energy from the data center heat, but in Ramco cements, to produce the cement, we need to produce the heat up to 4,000 degrees Celsius. It's called, we can call it as a kiln. Okay, so in this, right now we have set up the waste gas generation unit. So what it do, we are using the coal. Of course, we are using the coal for generating the 4,000 degrees Celsius of heat. So from the heat, there are a lot of gases will come. Through that gases, we set up the separate plant to produce the energy to reusing for our other factory operations. So it's really possible. So if you want to add anything.
I'm not a data center consumer, but what I've seen is that people are looking at a methodology of using the waste heat from the data center itself, because these computer racks that are there on the data centers, they produce a lot of heat, and they are trying to extract that heat in the cooling system and try to use it internally. I think that's the methodology that people are doing in terms of the design of the data centers itself. So I think Mr. Balakrishnan touched about the point about how to build it efficiently, and he mentioned a very interesting point. I would say just extension of that is every unit that is saved is a 1 unit produced, and today the pressure on renewables is so high that if there can be saving in the consumption itself, it's great, because that much less unit is required to be produced.
Yeah, I'll just quickly answer that. So I think when data center was developed, we were just pumping the full air into the open space, which is not the most efficient way of cooling the data center. Now the technologies have changed. We are containing and cooling the place. But going forward, I think people talked about it. Liquid cooling is coming, so that heat will not be generated in that place. It will be taken off from the source itself. So I think there are technologies being developed on this.
I think I also read somewhere that some of these Nordic countries are looking to put data centers underwater under the cold water, so they don't have to worry about that part.
Yeah. Hello. Yeah, this is Joseph from Great HR. So one of the word I think I heard from Mr. Balakrishnan is about being water neutral and carbon neutral in about 2035, I think, right?
Yeah.
So apart from this current eco initiatives, right? So what is new is going to come or being introduced to become water neutral or carbon neutral? So which will be specific to any industry sector, or it's going to be a countrywide
No,
initiative?
it's going to be countrywide. So if, so for example, water neutral, there are new methodologies to store water and use the water from the place itself. That is what is called as net zero. Whatever we are trying to take water for the project, we should produce it within that site. That's the simple meaning of that net zero. So like looking at rainwater storage or whatever treated water reuse, all that should be equivalent. Whatever you're consuming, you should produce within the site. So there are various technologies available to do this. I think it's a vast subject. I mean, there's different technologies to store water, you know, and also the reuse water, the treatment should be of that standard, and then we can reuse it within the complex. So that is one part. On the net zero, it's a bigger requirement than net zero water. Probably we can achieve in a larger space. For example, in our data center, we have created a pond to go towards that net zero water. So big pond, like a temple pond. This is what the EIA team wanted. So we have built that. In fact, it's almost ready. So the water will, whatever we want it to use, of course, data center uses very less water, but we are creating a pond to store the water for the usage. Okay. So the energy is much more difficult thing. But there are methods like and I mean, if IGBC also has got the carbon credit systems and other things, that is the one way of whatever you're going to consume, you have renewable energy being used in complete, and also how much carbon credit and other things. So there's a methodology to look at how you're achieving this net zero.
I just want to add that even in our solar operations that we are doing, we use dry robotic cleaning. Earlier, the industry used to use a lot of wet cleaning, but we are now using dry robotic cleaning. So we have to do wet cleaning once in a quarter. And so we cut down a lot of water consumption. And right from the design stage, we do it. So that's one way. And the second is we're looking at a lot of rainwater harvesting in our own plant. So that way we always be net positive from a water perspective.
Okay. So I think we are running out of time.
Good evening. Just a second. I'm Dheeraj from Indian Bank. Question to you. This is a good panel for renewable energy. My question is, main challenge in renewable energy is the transportation of energy, because the energy is generated at one place and it is transported to other place. So the place where it requires the energy, the devices and other things will require a lot of upgradation over a period of time. So what is your takeaway on this?
I think so far what we have seen is that we don't see any change in the way people have to do any upgradation to their infrastructure. All that they have done is if they don't have a SCM meter or a special energy meter, then they have to incorporate that because the DISCOMs need that for the purpose of accounting of energy. Otherwise, we've not seen any other change because you're still taking power from the grid, and it's just that when the power is injected from a renewable energy plant, when the electrons are flowing, it is not necessarily that the same green electrons are flowing to your plant. It could be some other electrons that are flowing there. You don't control those. So there's no change at the infrastructure, the customer end, except for this special energy meter that is required. That's what we have seen so far with our customers.
Okay, thank you. So already we are running out of time.
Thank you.
A lot of session is to go. So thank you. Thank you very much.